Hi there. My name is Rusty Evans, and this boy's name is Will Snyder. Now, it was Will Snyder. For you see, poor Will here is dead. He's been dead for about a day, and if you look closely and you feel, Will's muscles are completely rigid, totally flexed. Now, this is a condition known as rigor mortis. And rigor mortis is the stiffening of all the muscles in the joints in the body, and it lasts for about 1 to 4 days after death. Now I bet you're wondering, Rusty, how does rigor mortis happen? Now I'm wondering that too, and Will would be wondering that, but he's dead. So let's find out. Oh, hi there. I'm Rusty Stevens, but I'm sure you remember that. Now right now we're in the University of Kentucky. We're trying to figure out how rigor mortis works, so let's go find someone who can help us. Hi there.
Hello.
I'm Rusty Stevens.
It's nice to meet you, sir. I am Rick Morty.
Well, nice to meet you, Rick. All right, see, me and my program today, we're trying to teach kids about rigor mortis and how it works. All right, so would you be able to assist us in that?
Well, definitely. As an anatomy and physiology major in college, I can definitely help you out with that.
All right, well, let's go figure it out.
Let's go down to my lab.
All right.
So if we want to better understand rigor mortis, I think it's best that we understand sliding filament theory first, which is the most basic part of this. So I have a model over here. Let's go look at that.
All right, fantastic. So what is all of this?
Well, so if I want to preface this, let's talk about the neuromuscular junction, which is the start of all of this. The neuromuscular junction is going to act as my arm. My arm is going to be sending a signal. Signal is going to be representing my hand. The hand is going to be hitting the sarcoplasmic reticulum, which in turn releases calcium ions. These calcium ions are going to go on the troponin, which are these knots, as you can see on here. Okay. So I'm basically going to be hitting it on there, and I'll show you.
Yes! So I know a little bit about this subject myself. And so after the calcium bonds to the troponin, it causes the tryptomyosin, which I assume is this rope.
Yes.
It causes the tryptomyosin to unbind from the actin?
That is correct.
Alrighty. So now we have a non-binded actin. So tell me what happens next.
Well, the change in shape allows myosin heads, which are over here, to form cross bridges between the actin and the myosin. And as you can see here, it's able to go onto the myosin heads.
And this creates a shortening between the two, correct?
Yes.
And is that the contractions in the muscles?
That is actually what causes the contraction of muscles.
Oh, amazing.
So, right here we have these hearts, and these hearts are going to be ATP in this model. If you peel these back, these ATP are going to bond onto the myosin heads. So, we can put that right there and right there.
Alrighty.
Once bonded to the myosin heads, it allows this actin to come off of the myosin heads. And this is what makes them both return to their original state.
And that releases contractions.
Yes.
Alrighty. So, now that we've explained sliding filament theory to our audience and we've returned the model back to normal, can you explain to us how does this cause rigor mortis?
Well, when you have rigor mortis, it's basically an absence of ATP because the body is no longer producing ATP. When you breathe in, you're receiving oxygen. This oxygen is being used in cellular respiration to produce ATP. And this ATP, once it's not put on the myosin heads, the actin is no longer released off.
So there's nothing to release the myosin and the actin.
Exactly.
So your body stays contracted. Well, thanks for your help.
It was really nice meeting you. Yeah.
Alrighty, well, I think we've learned a lot today, so let's head back and go over it.
Alright.
So in the making of this video, we've learned about the sliding filament theory and rigor mortis. We've learned what the sliding filament theory is, how it works, we've seen a model on it, and we've understood how it causes and affects rigor mortis. And so now we know the reason why Will is so stiff, is so flexed. It's because he has no ATP to loosen his muscles. Well, It's been fun, class. I'll see you again next time. This is Rusty Stevens, signing out.
Just so you know, no human was harmed in this film. The only thing that died was my grade. I hope you learned a lot. Bye-bye.